Okay, good afternoon, everybody. So, I guess part of the motivation for talking about road mapping is that the FEMM Hub can possibly be about more than just individual specific research projects addressing specific research questions. There can be an element in the FEMM Hub of how we actually see the direction of travel for electrical machine manufacturing at a global level. And this, I suppose, was pointed out through the Scientific Advisory Board and Industry Advisory Board, where it was recommended that there ought to be a roadmap, a kind of more formal roadmap showing the flow down from high-level needs to the low TRL research that we see in the FEMM Hub itself. So this presentation, I guess, is talking through where we've got to in that process, which probably started at the start of the summer period. So in summary terms, the status is that we have started. We've done some work. We've developed a structure. We've kind of got a focus for how this is going to work. We've started to populate with information. There's an interesting piece of work that we have begun to do. But what I'm not going to present today is a finished roadmap, a finished story. There's a shell, if you like, that would benefit greatly from inputs from other bodies who've done roadmaps in related areas. ATI, we saw this morning, has done a lot of work in this area, but other bodies like that, but also from industry partners and other organisations and individuals that have data that is relevant to what we're going to try and do today. So let me talk through what we have got and the framework that we have put together, so you can start to see what we're trying to do. So the basic idea that we're trying to employ in developing a FEMM Hub roadmap is to work backwards from net zero in 2050. So this is a tried and tested approach that lots of people are trying to do, but in our case we're trying to do this specifically around electrical machines. So if we take net zero in 2050, what does that mean in terms of electrical machine manufacturing? And especially, as we work that down, especially based on what the FEMM Hub is, what does that mean in terms of the early TRL research questions and early TRL activity that needs to be developed from a research point of view? That's what we're trying to do with this. And absolutely, it overlaps and it links to other things that have been done by other organisations, ATI, APC, etc., etc. But this low TRL manufacturing focus on electrical machines specifically gives us a particular space that we think we're trying to operate in. So, just to re-emphasise, our aim is, we're trying to establish a clear line of sight from net zero in 2050 right down to the work that researchers do in the FEMM Hub. And in between that thing of net zero in 2050 and specific research, there are high-level challenges. Clearly, we've seen this morning that there is an expectation, a requirement, I guess, for better performance from future electrical machines. What does that mean from a manufacturing and process technology perspective? Probably, we assume that future electrical machines, 2050 electrical machines, will require some kind of future factory concept. And the reason for that is, I guess, not difficult to figure out. The future ways of making electrical machines will need to support a volume of product, which is probably different than it is today. They'll need to deal with dwindling resources, so we have this circular supply chain question. Because as we start to get to the numbers of electrical machines in circulation that there can be in the future, then the supply chain is a question, and the future factory for electrical machine manufacture will have to address standards that maybe some of which we know now, maybe some of which we don't know now. There will be expectations as to how these products are made in future. So the idea is to create the connectivity between this top-level view of net zero, what it means in terms of these kind of intermediate drivers, and link it back to what the researchers in the FEMM Hub are doing now, maybe what researchers do in the future. But this is not so straightforward. In fact, bridging this gap is not actually so straightforward because, we're all engineers in the FEMM Hub, and what we want as engineers really to be working on fairly non-contentious problems where the problem's clear and the solution, or at least the topic to be investigated, is fairly clear, and we can do some specific investigation. We can try things out. Net zero is much more difficult than that, because there are completely different approaches you could take to net zero. We hear about net zero flight this morning. There's a totally different approach to net zero you can take in terms of net zero flights. Net zero flight could mean we don't fly anymore. Sorry, but it's politically contentious. It's a difficult issue to deal with. And even at smaller scales, we have this mixture. When we talk about something big like net zero, there are so many ways of achieving it conceptually that linking that back to a set of research themes is difficult. So we have this thing in the middle, and the role that road mapping can play is it can help to structure the thinking that we have in filling this gap between a very high-level, broad, potentially contentious, high-level goal, but one that that most people would recognise needs to be achieved, and something that can be done from a research point of view by engineers. So the role of road mapping or part of the role of road mapping in this context is to basically say, we start from net zero. That implies a certain amount of products in service. Don't take these figures particularly seriously. I don't think I've done some projections based on documents that are out there. This is early stage work at the moment, so the intention of this is to give a cartoon, really, of the type of thing that we end up with. But the point is, we start with net zero in 2050. We make some assumptions about how net zero is achieved, possibly by some set of technology implementations that doesn't radically change the lifestyles that we have today. That tells us how many machines of different types we need to have in service. That points towards the fact that there are performance challenges that have to be achieved, and linked to what manufacturing processes need to give us. They also link to something about the amount of material that we might need to use, and an idea that in order to not exceed the capacity of material that the world can offer, maybe we have to implement circular economy processes. So this structuring of this very broad and open-ended problem is part of the road of road mapping. And luckily, there are things out there that help. So surprisingly, you might think government policies can help. So the government in the UK has set out government policy can change. And maybe at the moment, this is a key, interesting moment in time. Government policies can change, but the government does set out policies. It has set out policies for what it thinks it means by going to net zero, and committed money towards it, but also laid out some particular means and approaches that can be taken. So this, in the context of structuring this very open-ended challenge, this very contentious challenge, the role of government is important. We've heard this morning already that the role of bodies that represent and support different industry sectors is important. We saw the ATI presentation this morning as a case in point, but there are several of these kind of organisations, and in combination, that can lay out some of the structure that we need. And what do I mean by that? This is a complicated diagram. I don't expect you to even try to read the contents of this diagram. But in typical road mapping fashion, we can start to put some of the things that are in these policy and kind of industry body statements and documents into some kind of timeline, and start to see, well, this looks like what's intended from the different bodies that are out there at the UK level. And some of these are things that are likely to be or supposed to be mandated in law. So some of these are actually intentions. There will be bans on this. There will be a requirement for that. So there are certain things that are in that kind of ballpark. Other things are targets. The UK government has declared in its various policy document that it's targeting certain things. And some of these are really quite time-bound, and that, in our context of trying to structure this problem, that's useful. Other things are projections. Projections are useful, really useful. Lots of this stuff from the ATI, very interesting stuff. In the words of Paul Gascoigne, I never make predictions and I never will. Projections are also risky. We can't bank on these things being true, but they do give us something to work to. And if these are recognised, as a lot of them are in industry, then that gives us something to go to. We can also we can take things like the industry sector view that we get from ATI or from APC for that matter, or other things that are published elsewhere. And we can start to use this. One of our challenges in looking at the shape of manufacturing in future is production volumes. Very simple terms, and don't take these figures particularly seriously, but when we've been through this a little bit more thoroughly, you can start to get to a point where you can work out, or you can project and estimate based on the projections that are already out there from other sources, how many electrically powered aircraft we might have, based on the idea that we're only really talking about regional and sub-regional, as far as I can understand from ATI. How many vehicles there might be, what power output of renewable power there might be, etc., etc. We can start to get a view of what that implies in terms of volumes. We can also start to do, and then assuming we have good data at the next level down, which at the moment I don't think I have, hence I'm going to be asking for help in a moment. Don't be surprised when I ask for help, because that is going to happen if I get to the end and I don't get stopped. We can start to project, if we know how many vehicles there's going to be, if we know how many electrically powered aircraft there's going to be, if we know how many watts of power have to be generated through renewables, we can make projections about how much material is going to be needed in the world. Now, I don't think these figures on here are reliable, so let's not take these figures particularly seriously. But whatever figures we use, based on what I understand it seems problematical. Either in the context of rare earth, of specific rare earth elements, or in the context of more widely used materials like copper, that material availability is potentially a big challenge in this whole area. But in terms of really nailing this and turning this into a reliable piece of work, we've got to get to a better standard of data around this. What we can also do, and what we have done, is we can do a little bit of brainstorming, and we can start putting challenges, things that we know are barriers that need to be overcome in getting to the performance and the production volume and the standards that we think we have to achieve for electrical machine manufacture under net zero. Again, lots of detail on here, which I don't expect you to read, but in summary terms, what we can see is, as in all forms of manufacture, we assume that there's an important role for data. And I think partly in the electrical machine context, some of that is about informing through life decisions, especially because it appears that we maybe have this issue of not enough physical resources to satisfy the requirement that there'll be in future. There's a question about standards, there's a question about end of life, there's a question about factory and supply chain operations to meet volumes of production that we have to have, that is a manufacturing issue that needs to be overcome. And as I've highlighted and telegraphed already, we have this challenge of dwindling resources. If we're going to have many more higher performance electrical machines in service than we have now, then resources is potentially a problem. And that could help us to work towards the idea of a future factory concept. We've got some work to do around this, but part of the output of this process for a FEMM hub roadmap will be a factory concept, a manufacturing concept. And you've seen through the tour today, one of the themes that runs through the FEMM hub, through several activities that are going on in the FEMM hub, is this idea of being flexible manufacturing processes that can adapt and can allow us to have flexible and configured products that can be optimized for particular purposes. Efficiency, connectivity, resilience, suitable use of automation, I guess, all the things that you would expect to see. So as part of the output of this process that we're in the middle of at the moment, there will be a more worked through factory concept that we develop. But of course, as we've heard a lot of this morning, there's going to be manufacturing needs that underpin the achievement of performance in future electrical machines. We've seen the projections and the requirements that we have, and I've chosen some measures of performance. I'm not the best person to get into a debate about what the best measures of performance are for electrical machines, but the fact is there are measures out there, and they give us a standard to achieve in the future. They give us a gap, basically, between what can be done now and what needs to be done in the future, and then they help us to set directions. And again, we can start to set out a view, and again, this is in more detail than we can talk through in this short presentation, but we can set out a view as to where the barriers are that need to be overcome. On a performance timeline, manufacturing processes that drive performance improvements. And for any one of those, we can start to expand, well, what does that actually mean? What are the underpinning challenges and what are the underpinning activities that we would need to pursue? And similarly, when we talk about particular things, when we talk about, in this case, power density or torque density, we can start to see some of the key factors that need to be worked in order to develop that, and we can build up specific content. And again, this is just to give you an indicator that there is work that's gone on to a level underpinning this. We can start to build up a view as to where we think improvements might come from. And the idea will be, and this was kind of alluded to a bit, I can't see that sign with my poor eyesight, but I can see that there's a time restriction. So there you go. This is the problem of old age. We can see that we can, what we want to be doing, I guess, is stacking up all of these performance gains, a bit like the nice, simple step diagram that was shown in the ATI presentation. We can start to stack up where some of these benefits come from. And from the FEMM Hub point of view, what's important is to link that to where there are research questions, what those research questions need to be. Because some of these performance improvements aren't really a matter for engineering research in electrical machines. Some of them are industrial organisations getting their act together, to be honest, and decisions being made and so on and so forth. But some of these things are actually research challenges and need to be worked through. So the idea is that will give us a view. We can already see where the FEMM Hub fits and plays around different, the different parts of an electrical machine, and we can see a bigger view of that going forward, I guess. So the idea is we can start to see the impacts on where research fits for different parts, different components, different modules of an electric machine, etc. So to wrap up back where we started from, the idea of what we're trying to do with this is to take inputs from policy, industry bodies, the academic world, anybody else who's prepared to provide information to us and give us some better structure to manage this gap that we see from a big, broad challenge that is clearly related to electrical machines to something that we can do about as researchers. We have this gap. What does net zero mean for electrical machines, right down to the work of individual researchers? The structure helps us to fill this gap, and it helps us to move us into a situation that is maybe a bit less contentious. The problems may be a bit clearer, even though the solutions might not be clearer, and it can make the gaps smaller from where we are now to where we need to be. We can move from a highly complex problem into a much more tractable problem. We've still got a lot of work. We've started, basically. We've spent some time over the summer and we've started this process off. There is more work to do on this, and there's definitely much more work to do in making this into something nice and simple and digestible and communicable. And for this to be influential, which I think it can be, we probably do need to find a way of making it fairly straightforward and influential. But critically, we do probably need to have more inputs from more people in order to make this work and establish this clear line of sight from the big overarching goal of decarbonisation right down to specific pieces of low TRL research. So we need some help. We need to get some better data. We need to get some more reliable data. We need to get some data that is from industry, bound in the industry partners that we have in the FEMM Hub. And we need to try and structure that, build that onto the framework that we've already put together so that we can do something that can be genuinely influential, both from the point of view of directing future research in the FEMM Hub, but maybe more broadly as well, and maybe more helpful as well to industrial organisations who are making decisions around this on their own part. So there you are. Thank you very much. That's all I've got to say.